right, so we're going into the next section, 3.2, which is still looking at systems of equations, but now instead of solving systems of equations by graphing, we're going to solve systems of equation by using two different algebra techniques. So I'm going to make two short videos. I'm going to make one on each technique so that way you can watch it and then practice it on Delta Math and then watch the next and then practice it on Delta Math. So our warm-up here that you're going through is actually kind of getting you ready for the second type. The idea is that when you are working with expressions in terms of x's and y's or any variables, you can actually add those expressions together vertically. We're used to adding them side by side with like terms. So when I add this first one, 3x plus 5x is 8x. 7y plus 1y is 8y. So you can actually do like a vertical addition or subtraction with our expressions. Next one, my negative 2a and my positive 2a will cancel. So I'm just going to put a line through it. And then 4b minus 7b is negative 3b. The next one, you actually have to distribute before you can do your vertical addition. So I'm not going to do anything to the 4x plus 7y, that top expression. But I'm going to distribute the negative 3, so I get negative 6x and a positive 3y. Now I can add my columns together. 4x minus 6x is negative 2x, and 7y plus 3y is 10y. We're going to use that here in a bit. So first, let's just talk about what the methods are. We're going to do one method at a time. So 3.2 is solving systems algebraically. There are two methods to use algebra to solve. The first method, and the one this video is focused on, is called the substitution method. So with the substitution method, the best time to use this method is when you have an equation that has an isolated variable. Isolated variable means you have something like y equals and then everything else is on the other side, or x equals and everything else is on the other side. And it could even be different letters of the alphabet. It could be like a equals 2b minus 5, something like that. The idea is you're looking for an isolated variable, so a variable that is totally by itself. The process is that you're going to take what that variable equals and you're going to plug it into the other equation to help you solve. When you finish these, all of your answers are going to be written as an ordered pair. So when you are done with all of these, no matter what technique you use, whether you graph from last lesson or whether you use substitution or the next method, your answer will be x comma y. Or if it's written as different letters, we always write it in alphabetical order, and it's the two values, the a and the b, the x and the y, that make it true. So I'm actually only going to do two substitution with you because I feel like it's the one that students usually have the most experience with. So what you're looking for is my equation that has the variable isolated. In this case, the very first equation, you have the y isolated. So here's what I do. I like to circle it, what it equals, and then you're going to put it into the other equation for that variable. So since y equals x plus 1, we're going to substitute y with the value x plus 1. So it looks like this. 2x plus, instead of putting y, we're going to put x plus 1. I think it's a great habit to put whatever you substitute, put it in parentheses, and you'll see as you write it if the parentheses are really needed. In this case, I don't really need the parentheses because there's nothing in front of it, so I can immediately drop them and start combining like terms. So 3x plus 1 equals 7. Once you have this all in one variable, you're going to solve. So we're going to subtract 1, divide by 3, we get x equals 2. If you stop there, you're only partway done because that's the x value. You have to have the y value. So you're going to take this 2 and you're going to put it right back into what you circled. So the other reason I like circling is so I can kind of remember where my eyes are supposed to go when I finish this. So if I put 2 back into there, 2 plus 1 is 3. So my answer is the point 2 comma 3. Visually, it would be the point where these two lines intersect. Algebraically, it would be the one set of values that if I put in 2 for x and 3 for y, it would make both equations true. Next one, you have this entire 2x minus 1. It's going to go in for y. So I'm going to have 3x minus, instead of y, I'm going to put that circled quantity, 2x minus 1, equals negative 1. The parentheses are important now because they tell us that we need to distribute that minus sign. So you have 3x minus 2x when I distribute the minus sign, and then a plus 1 when I distribute the minus sign. You're going to combine like terms. 3x minus 2x is just 1x, or x. Subtract 1, you get negative 2. That is half of your answer. You're going to take that -2 and you're going to put it right here in that circled expression. So you're going to have 2 times -2 minus 1, which you can do in your head or with your calculator. You get -5. So my answer is -2, -5. That is the point where these lines would intersect. It's the x and y values that would make each true. I want to just mention one other thing because sometimes the simplest ones do throw students. So I'm just going to kind of add a slide in here. If both of your equations are y equals, so if it's like y equals 2x plus 5 and y equals 4x minus 11, just kind of making up questions. Sometimes students get a little confused, like, what do I do here with this? You're going to take this entire 2x plus 5 and put it on the other side. If both are y equals, then you can set 2x plus 5 equal to 4x minus 11. Essentially what you're doing is, since they're both equaling to y, you're setting them equal to each other. From there, then, it becomes, again, very simple to solve. Nice with this one is you don't have as much parentheses to worry about. And then you're going to add 11. So you get 16 equals 2x. So x equals 8. Once you know what x is, you can go back in. You can actually put it in either one. You could put 8 there. Or if you want to be really sure of your answer, you could put 8 in both and make sure you get the same answer. When I put 8, I'm just going to put in the top one. 2 times 8 is 16. 16 plus 5 is 21. So my ordered pair would be 8, 21. And you can double check, make sure that when you put an 8 in here, you also get 21. So that is called the substitution method for solving systems.